Hi everyone, my name is Anna and I am a senior in computer science.
Hi guys, my name is Malvika. I'm a sophomore in computer science.
Hello, my name is Sachi and I'm a junior in statistics.
Today we're going to go over our project of exploring characteristics of phishing URLs and training an LLM model to be able to predict if a URL is valid or invalid. This project is specifically interesting to me because I work at Microsoft as a software engineer. And a few weeks ago, there was a data breach that stemmed from URL phishing. It compromised hundreds of senior executive accounts and caused user impersonation, unauthorized data extraction, financial fraud, and much more. And URL phishing is a major security issue in today's technological world.
First, let's talk about our dataset that we sourced from Kaggle. It contains information about invalid and valid labeled URLs along with their various characteristics like the number of dots, hyphens, underscores, presence of HTTPs, and the length of the URL. With this information, we can point common characteristics of valid versus invalid URLs with regards to these characteristics.
We removed the sensitive words column from our dataset. While it may provide significant results, we are unsure of how to interpret what sensitive words would be and how they could fit into our dataset. This uncertainty stems from the complexity of sensitive language, which could vary based on cultural perceptions or even individual ones. Including this variable could lead to inconsistent results and even skew the overall results of the study.
Hypothetically, we would have liked to add the actual URLs to this dataset. However, we found that they were not good enough and would not add good enough value to our analysis.
Okay, and now we are going to go into an explanation of our code. We will get into an analysis of the results as we show you it. So first, we are reading in our data set. We are sampling for 2,000 data points to narrow it down a little. We are then grouping by valid URL and HTTPS. So what this is doing is that we have a data set that shows us if a URL is valid or invalid, and then the characteristics of each. So here, a little slow. Here we are creating pie charts that show valid URLs and invalid URLs. So we are grouping by if the URL is valid or not. For invalid URLs here, we will count the number of times that HTTP or HTTP shows up, and then we will plot it into a pie chart. And then we do the exact same thing for the valid URLs. So as you can see here, most of the valid URLs are HTTPS, which is secure, and most of the invalid ones are HTTP. So after this, we go into filtering out the data set to extract the ones that are valid. Valid are the ones where it is equal to 1. And then here we are creating a bar chart. As you can see below, this is for the URL length and path length. So what we do is we count the number of invalid and valid URLs like before, and then we are plotting it in the bar chart based off of the length of either the URL length or the URL path length. So the URL length is the entire length, and then the path length is everything after .com/. So we are plotting the bar chart, giving the labels, title, and adding a legend. So as you can see here, the invalid URLs are much higher and longer than the valid URLs. And then here it shows the path length versus the URL length. Next, we are going to go into the characteristics, which was the majority of our project. The characteristics are all of the different things shown here, all of the different columns. So here we are having a Python dictionary that shows the column name and then what our title of it will be. We have a function here that is going to take in the characteristic in the title, which is the characteristic in the title. And then all the way down here, we have a for loop, which calls this different function over and over for each of the characteristics. So each time this function is called, it is going to print out these two graphs for invalid and valid for a given characteristic. Now looking at the function a little bit more, it is adding a title. It is then creating the histogram for the characteristic and valid or not. It then adds some labels and a title. This section right here is for the max count. This is important because we wanted to make sure that the graphs were the same for valid and invalid, so that they have the same y-axis so that the data isn't biased or skewed once we're looking at it. After all this, we then do it for the invalid as well, and then we do the titles and print out the show. This is again for the y-axis. As you can see, the invalid URLs have much higher number of characteristics, which means that invalid URLs have a lot more of these things, such as number of ors, number of ands, number of wwws, number of .coms. And then finally, we are going to go into our model training. This is an issue that we ran into. For the test train split, you're only able to give one parameter. So we were unable to give all of these in these parameters. So we made an array for it, which solved our problems, and we gave all the characteristics. We then plugged it into test train split, and all this was given from the lectures. We can then see all the different test size percentages and their accuracies. For our hand test, we decided to go with an accuracy of 20%, and then we trained a model for that. We give it some hand tests, the ones given from class. And then we started looking at the different characteristics of each of these hand tests, how many dots they have, how many ands, HTTPS, .coms, similar to above. And then we put that into a data frame, and then we can predict our model based off of it. And then here we are printing out what our prediction is, and then whether it is valid or invalid. And as you can see here, here is our training, our accuracy, and then finally, if it is invalid or valid. As you can see here, it is a little wrong. The AI did not get it quite right because youtube.com says invalid, but it should be valid.
Overall, everything went as expected, and most of our predictions that we made before making the visualizations were accurate. We were surprised by our machine learning models predictions, especially with the youtube.com, as Anna mentioned.
Overall, though, thank you guys so much for listening, and we hope you learned some interesting information about the characteristics of phishing URLs.
Thank you.